So friends, let's learn electric field due to infinite charged line wire. For this, we have to take an infinite line charge wire cross section. So let us have a cross section of an infinite line charge wire. Let charge is plus here. So it is a wire. When you draw a Gaussian surface, the Gaussian surface is cylindrical. So let us draw a cylindrical Gaussian surface. This is a cylindrical Gaussian surface of length L and radius R. So cylindrical Gaussian surface have three surfaces. Surface number 1, top surface. Surface number 2, curved surface. Surface number 3, base. Let lambda is equals to Q upon L. This is said to be linear charge density. This is linear charge density. Now on the top surface, let us take a small surface area known as ds. So it is pointing upward, ds, and electric field is towards x-axis. So this will be electric field. ds and electric fields are 90 degree at angle. Let us take another surface on second surface. So again you have ds here. Electric field is on the same direction. So theta equal to 0 degree. We have a third small surface on third surface. This is ds and this electric field E. So the theta is 90 degree here. So we have drawn the Gaussian surface and we have seen that there is three surfaces. So now we use the Gauss law. According to Gauss's law or theorem, you have phi is equals to closed integration E dot ds, which is equals to Q upon epsilon naught. Now this closed integration can be opened into three parts. For surface 1, for surface 2 and for surface 3. So open it for three parts. You have integration E dot ds surface 1, integration E dot ds surface 2, integration E dot ds surface 3, which is equals to Q upon epsilon naught. For the first surface, the angle between ds and E is 90 degree. So we have E ds cos 90 degree, integration surface 1. For surface 2, you have the angle between E and ds is 0 degree. So E ds cos 0 degree, surface 2. For third, you have E ds cos 90 degree and this is surface third, which is equals to Q upon epsilon naught. Q upon epsilon naught. Cos 90 is 0. Cos 0 is 1. So you have 0 plus E integration ds surface 2 plus 0 is equals to Q upon epsilon naught, because you know cos 90 degree is equals to 0 and cos 0 degree is equals to 1. Now this is the second surface. In second surface, ds is a small part. When you integrate it, you get the surface area for the whole surface for second surface. So the surface area of second surface, that is curved surface area of cylinder, is 2 pi RL. So you will write here, this is 2 pi RL, or it's better to write on the upside for your visibility. So you have E into 2 pi RL, which is equals to Q upon epsilon naught. Why? Because integration of ds second surface is equals to 2 pi RL. Now second part is, we know that lambda is equals to Q upon L. This is said to be linear charge density. So you have Q is equals to lambda into L. So put the value of Q here. So you have lambda L upon epsilon naught, and on the LHS side you have E into 2 pi RL. So here L will cancel out and you get the expression for electric field. So electric field E is equals to lambda upon 2 pi epsilon naught R. This is the expression for electric field. From here you have E is proportional to 1 by R. E is proportional to 1 by R. So you get the expression for electric field. Moreover, you can write like this also. E equals to 1 by 4 pi epsilon naught into 2 lambda upon R. What we have done? We have multiplied numerator and denominator by 2. So this 1 by 4 pi epsilon naught equals to K. So you have E equals to K constant 2 lambda upon R. You can memorize this formula. This is easy. 2K lambda upon R. Now if you draw the graph variation for electric field and R distance, variation of E versus R, then let us place here E and place here R. As you know that E is inversely proportional to R, so here E and R have a curve nature in which this distance and this distance are same. If you draw another graph in which you want to take E here, and on the x-axis side you take 1 upon R, then E is directly proportional to 1 upon R, so you have a linear relation. So these are the two graphs for variation of electric field versus distance R. Let us understand numerical based on this topic. Here I am giving you a charged wire. This charged wire produces electric field. Electric field E is equals to 9 into 10 to the power 4 Newton per Coulomb electric field. And let the distance between these 2 points R is equals to 2 centimeter. Then what is the value of lambda? What is lambda? Lambda means what is linear charge density. You know the formula. In this case, electric field E equals to 2K lambda upon R. So you have E equals to 9 into 10 to the power 4 and 2K is 9 into 10 to the power 9. You don't know what is lambda, which we have to find. R is 2 centimeter. This means that 2 into 10 to the power minus 2. So cancel this 2, cancel this 9. So you have 10 to the power 4 is equals to 10 to the power 11 lambda. So lambda is equals to 10 to the power here this is 4 upon 10 to the power 11. So this you have 10 to the power minus 7, and unit of lambda is equals to charge per unit length. So unit is coulomb per meter. So it is coulomb per meter, which can also written as 10 to the power minus 1 into 10 to the power minus 6 coulomb per meter. 10 to the power minus 1 means 0.1 and 10 to the power minus 6 means micro coulomb per meter. So the answer lambda is 0.1 micro coulomb per meter. Thus you are enjoying physics. So do like, share and subscribe my channel Physics Gold Ravi Kumar. Thank you.